Welcome to Is It Observable? The main objective of Is It Observable? It's to provide tutorials on how to observe a given technology. Today's episode we will talk again about Kubernetes, and we would be focused on the software architecture providing extra observability on our cluster and more. And I'm referring to a specific technology, and I'm pretty sure you know the one I'm referring to. It is ServiceMesh, and we are going to talk about one of the most popular service mesh, which is Istio. So, if you enjoy today's content, don't forget to like and subscribe to the channel. We are going to produce more episodes in the coming weeks. So please let us know if you have a specific topic that you would like us to cover. So what are you going to learn out of this episode? So first, we're going to briefly introduce the microservice architecture. You all know what it is, but it makes sense to remind us what it is. Then we are going to explain and present ServiceMesh. Next, we will introduce Istio, and we will then jump into a tutorial where I would like to deploy Istio, and I will use Kiali and Grafana to build dashboards showing us the traffic of our microservices. Alright, so let's jump to the first section, microservices. The microservices has been a hot topic since several years now. There are a lot of great benefits of moving and building microservices. First, it's easy to build. Then you have the ability to be independent in deploying your services. And you can also have the diversity of technology. So someone can build a service in Java, the other one in Go, in Node. You don't have to have one standard language, because at the end of the day, everyone is in charge of its own service. And also it's easier to scale in terms of development. So it's a natural stack, honestly, to move to the cloud. Hallelujah. So when building a service-based architecture, there are several things that we need to consider when it comes to communication. So let's take the example of the hipster shop. So we used it several times in our tutorials, and we are going to still again use the hipster shop. So in the hipster shop, you have a front-end service that communicates with a product catalog service, the shipping service, the recommendation service, and the cart services, and so on and so on and so on. So there are clearly some dependencies. So those services need to talk to each other. So in order to let those services communicate to each other, there are a few things that we need to manage. The first, so the retry logic. If the cart service is not able to reach to the payment service, for example, you can add the retry logic in your code to handle the exceptions and retry the request several times. But the big question that we have when we implement those retry logic is, how many times should I need to retry to avoid putting extra pressure in our system? So that's the big questions. And the other thing is, if we do start putting this logic in our code, then it means that we have to make sure that the other services of our organization is also implementing that retry logic. So remember, you're going to have one service in Java, the other one in Go or Node. So you have to make sure that all those diversity of technologies using the same retry logic. The second piece is the authentication logic. If the service cart needs to communicate with the payment service, it needs to know the authentication mechanism to use to be able to communicate with it. And the payment service needs to have the authentication layer added in the code to be able to accept the request from the cart services. The other piece, so this could be also included in the code. The other angle as well is certificates. I could clearly want to implement SSL in all the communication within my cluster to increase the security, which makes completely sense. But again, if we start to implement it in our code, instead of communicating in HTTP and we need to have TSL or TLS or SSL, then it means that we are gonna basically add extra tasks in the shoulder of our Kubernetes administrators. They will need to rotate regularly those certificates to guarantee a good level of security. Next is observability. I mean, is it observable? Of course, we're going to talk about observability. What do you mean? What do you expect? But here, if we want to expose metrics in our services, then and know, for example, how many requests per second, the latency of my services, the number of errors, the HTTP codes, who is calling me, who I'm calling. I mean, I can clearly do that in my code. So I can add, for example, the Prometheus client in my code, and then my service will become a Prometheus exporter. And I will be able to collect those counters, those metrics from our service with the help of Prometheus and then Grafana to build dashboards and alerting rules. You probably want also to add on top of those metrics some tracing as well. So to understand, for example, why our response times is increasing and where do we spend the time. For example, I got the front service, which is calling the recommendation service. And this recommendation service is calling the product catalog and the cart services. So if, for example, my response times is about above 1.5 seconds, which is quite high just in the cluster, we would probably want to know, where do I spend time? I mean, is it the recommendation service, the product catalog, or the cart services? So definitely tracing will allow me to figure out where I'm spending time. So to enable tracing, we can add also, similar to the metrics, extra libraries, and that will allow us to instrument the code. That will allow us to get the right level of traces, and then we can ingest those traces somewhere, so we can then build dashboards and do all the diagnosis on how our services are behaving. Next is traffic split. I mean, this is more, you probably want to implement canary releases if you're working in the Microservices environment. For example, I have the version 2 of my cart services, and I'm going to deploy the fresh new cart service version 3. We did some testing, but I don't know. There is some glitch. We saw it, but we didn't resolve that issue. So I may want, for example, to basically have a small portion of the user utilizing the cart service version 3, and the rest will use the cart service version 2. So I can create a traffic split that will send 90% to the version 2 and 10% to the version 3. To implement this in our application, it's more complicated. You don't do that with just code level. So you have to be clever, you have to be smart, but you will see, we have an answer later on. And last is the security logic. I mean, we can build ingress in front of our cluster. We probably have some firewalls in front of our cluster. So all the traffic comes in our cluster. They are going through the firewall. So basically we control what's going in, what's not going out. So that's okay. So I think we're secure. But then the main problem is that inside of our cluster, everything turns without any restrictions. Without, I don't know, I can do plain HTTP. And if I am at the cart service, I can reach out to all the services that are around me. I have no limitation. So from a security perspective, it seems quite dangerous, which means if a hacker is able to enter in our cluster, then he can basically reach out to any service. And it means that our data could be sniffed out of our cluster, And so that doesn't seem very safe. So we need also to add some security logic in our cluster. We clearly want to add logic where we will basically define which service can talk to each other and to avoid exposing all the services to each other. So at the end of the day, if you look at all those requirements just for communication, it means first, the dev team needs to work on the application logic, because we're building microservices, so there's some logic behind, so I need to have that. Then we saw that there's so many communication requirements there, so I need to add on top of that code the retry logic. Then I need to add on top of that the authentication logic, the certificate management for TLS, SSL, the logic to instrument, to expose metrics, the logic to expose traces, the traffic split if I want to do it, and everything related to those security aspect. It means that we're spending only, let's say, 40% to 60% of our development effort on our feature, and then the rest is only for communication, which means we are spending less time on providing value for the business and for our users. Wow, that is dangerous. And basically, who is going to maintain that code? It doesn't make sense. I mean, we cannot add more and more code in the shoulders of our developers just to manage the communication. So how can we manage this challenge? But I have a solution. To avoid this extra task, we have a technology called ServiceMesh. ServiceMesh is a dedicated infrastructure layer that will facilitate the service-to-service communication. ServiceMesh will make your communication smarter and will automatically manage the retry logic, the traffic split, the authentication logic, the certification management, the observability layer, and more. The main idea is to put all this communication logic into a sidecar proxy, which means we only have to focus on building the business logic related to our application, and then we build our container, we put it on a pod or a service, and inside of that pod we will add another container. In the pod we'll add another container called the sidecar proxy that will manage the communication layer for us. So what is a sidecar proxy? Well, the concept is very simple. The ServiceMesh has several architectural components. It has the control plane that is in charge of managing for us the communication of our service. The control plane will automatically inject extra containers in the definition of our pods by adding that proxy. The mechanism is called sidecar proxy. Once the proxy is installed on our services, then our services won't communicate directly to the other services. In our example, we took the front-end services. So the front-end service will send a request to the sidecar proxy first, and then the sidecar proxy will reach out to the sidecar proxy of the card services that will forward the request on local hosts to the real card service. The sidecar has a proxy configuration that will allow us to turn on the retry logic, the certificate, and also to rotate them automatically, the authentication, and also exposing default metrics from our services. And all that without adding any extra line on our services. Wow, that is magic. And because the sidecar proxy are managed and injected by the control plane, it means that we only have one location to configure. Oh my God, it's also simplified the administration. It's great. So the network layer will be managed by the control plane, and all the proxies will be automatically added in our pods. So there are several ServiceMesh solutions out there. I mean, there is Linkerd, there is Istio, there is Superglue, and more. So Istio. Istio is clearly a service mesh. The Istio architecture utilizes a specific proxy called Envoy. So it's another open source product. So Envoy will be the proxy that will be injected as a sidecar proxy. The control plane of Istio is called Istio-D that will allow us to configure, discover, and manage our certificates. The architecture is structured with the control plane, Istio-D, and the data plane with the various Envoy proxy that will be managing the communication between our services. So how do you configure Istio? Well, the main idea is to avoid changing our Kubernetes deployment files by adding all those communication logic. We want to avoid that as much as possible. So the idea, we're going to separate it by defining the communication in specific CRD files, custom resource definition, that will extend basically the Kubernetes API. So the configuration of Istio will be done with the help of new CRDs that manage the traffic, the routing, the retry logic, which service can communicate to each other, and so on. So there are two main CRD that we'll talk about. So the virtual service that will define how to route the traffic to a specific destination, the destination rule that will configure the policy of that traffic, sort of a load balancer, I would say. So those two CRDs will be consumed by Istio-D and translated it to a specific Envoy settings. Istio push the changes to all the Envoy proxies, which means the Envoy proxy doesn't have to communicate to Istio-D to route the traffic. He received the rules, and then Envoy proxy are independent. Istio-D is composed on several components. So Pilot, Citadel, and Kiali. They used to be separate components that we had to deploy in the previous releases of Istio, but now they've been automatically added in Istio-D. It makes simpler in terms of deployment and management. So Pilot is responsible for configuring the proxies at the runtime. Citadel is managing the certificates and will rotate those certificates as well. Kiali is responsible for validating the injections, the aggregating, transforming, and distributing the configuration within Istio. Istio-D has a dynamic service discovery that is an internal registry for services and their endpoints. So basically, every time you deploy a new service, it will be automatically registered in Istio, and with the help of that registry, the Envoy proxy will know how to route the traffic to the relevant services. Istio-D acts like a certificate management, and Istio-D get the tracing and the metrics from the Envoy proxy and expose it in a Prometheus data. Wow, that's great. So tracing and metrics are just generated out of the box. I don't have to add extra coding or instrumenting. I will get some details on how my services are behaving. This is just great for us. Istio has also an ingress gateway. It's the entry point basically for our cluster. So Istio Ingress Gateway is an alternative to NDNX Ingress Controller. The gateway will redirect the traffic to the incoming traffic of a cluster to one of our services, and that will be done by using virtual services. The traffic will look like this. The request will hit the gateway will evaluate the virtual service rules and how to route the traffic, and then it will reach out to the Envoy proxy and will forward the traffic to the service using localhost. If a service needs to communicate with another service, the Envoy proxy will use the virtual service, the destination rules, and will reach out to the next Envoy proxy. The proxy will gather automatically metrics from the services, the user of the services, and will send it back to the control plane. When deploying Istio on your Kubernetes cluster, you will need first to install Istio-ctl. It's a command line. You will see that later, and we use it to configure Istio. And with Istio-ctl, it will install Istio core and Istio-d. When you install Istio, in fact, you will have to specify the configuration profile. So there are several configuration profiles in Istio. But once you have installed Istio, Istio will be basically creating automatically a dedicated namespace in your cluster called Istio system. And in that namespace, you will find Istio-d, the control plane, and the gateway. To enable the discovery of your services, you will have to label one of your namespace with the right label for Istio, and the label I'm referring to is Istio injection enabled. So you'll see that we will use it during our tutorials. So if you have several namespaces that you're interested to have the automated discovery, don't forget to label those namespaces. So Istio has add-ons as well, which is amazing. So add-ons for monitoring, tracing, and visualizations. So like mentioned, there are several configuration profiles. When you install Istio, you have to precise which type of configuration profile you want to install. So the first one is the default. This is mainly used for production usage. The second one is demo. Demo is designed to showcase Istio, and probably in demo you're using Minikube or Key3s, maybe less resources. So basically it's been designed to run with the limited resources. Minimal is basically Istio will only install the control plane, and that's the only thing. And then you have external. External is to basically handle remote communication with remote cluster. It means if the control plane has to manage a remote data plane, then this will be the right installation. And then you have empty. Empty, basically nothing will be installed. And last, you have preview. So preview, basically, you will deploy Istio with the experimental preview features of Istio. There are, of course, more advanced objects in Istio, like the service entry to mesh external services. You have sidecars to limit the set of services that the Envoy proxy can reach. You have the virtual services, we mentioned that will allow you to define timeout, the retry logic, the circuit breaker, and fault injection. That's a cool feature as well. While the destination rule will allow us to define all the logic related to certification policy, traffic splitting, and so on. All right, let's jump into the tutorial.
All right, so like every tutorial delivered by Easy Observable, you will always find a GitHub repository with the various steps of this tutorial. So here it's the obviously Kubernetes ServiceMesh Istio. I'm going to skip few steps of this README file, which we are seeing here, because I already have the cluster built. I already have deployed the hipster shop. So I'm going to go directly to the step where we're going to install Istio-ctl, which in fact I already did, to be honest. So I already have added the Istio-ctl as in my path, but you can do it if you didn't do it. So let me just check. So if I do Istio-ctl, all right, so you can see that I have it now. So now, because we have the command line, we need to install it. And like explained previously, we need to precise a configuration profile for this installation. So here, we are going to use the profile demo that will deploy Istio-d, the ingress gateway, and the egress gateway as well. So let's do this. All right, so now Istio has been deployed. So let's do a kubectl just to get the services that has been installed in the Istio system namespace. As you can see here, we have two services, the egress and the ingress gateway. So those has been deployed. We have some predefined port open for the ingress. And because we want to expose outside of the cluster, you will see later on, hipster shop will have to adapt the settings of this ingress. Now, let's do a kubectl, and on the same namespace, I'm going to look at the pods of Istio like this. So now we can see that we have Istio D. Istio D will do the magic. But before we do anything, go further on this tutorial, we need to label the hipster shop namespace because we want to let Istio automatically discover the various services. So here it is. So Istio has been injected. Now I am currently on the repository with the content of this repo. If I do ls here, you can see that I have a hipster shop folder. And what I would like to do here is obviously delete hipster shop and reapply it. Why? Because I want to let Istio discover those new services. And if I don't delete and reapply them, he won't be able to discover those. So let's apply it. So kubectl, same thing. So basically I just have to remove delete and replace it by apply. Like this. Now it's been deployed. And then what I want to do here, while we are here, jump to the directory where I have Istio installed. Oh. Right, and then you can hear I got an Istio folder here with the that I have previously installed, and in that directory, installation directory of Istio, you will have it as well. You can see that we have a sample directory, and in that sample directory we have an add-on directly. And the add-ons, let's show it. We have lots of various configuration. So let's apply each of those one by one. So let's do first the Prometheus. So let's do that. All right, so now it has deployed Prometheus, a config map, and everything in this specific namespace. Now let's do the same thing with Grafana. Grafana has been also applied, and it also comes along with a few dashboards. Now let's do the same thing with Jaeger, point file, and last I would deploy as well Kiali. So everything goes well. So let's have a look now at this namespace. kubectl gets the services of the Istio namespace. All right, now what we can see here in that namespace is we have Prometheus available, we have tracing, we have syncing, we have Kiali, we have tons of them. So what I would like to do, we have also Grafana. So Grafana is listening to the port 3000 here. Prometheus is on the port 1990, and Kiali is on the port 20001. So I would like to, and we can see we have our ingress with a couple of default ports. So what we could do here is basically I'd like to edit this one. Why? Because all right, so now let's look at the Istio. So here we have the ingress gateway. Let's have a look at it. Cat ingress gateway. As you can see here, what I have decided to add in this file is those following ports. So I have a port for Grafana, which will be the 8080. I have a port for Kiali, which will be 8181. And also I have added the port 80, which is HTTP, and this will be used for our hipster shop application. All right, now, so I have to apply this one, of course, obviously. So, all right, now it's been configured. So let's check it out. Now, if you look at the get SVC we will see the new ports that has been added here. We can see that we have the AT80, ATT1, and AT. And by the way, I didn't show you something which is important, is the pods of the hipster shop namespace. Because remember, we deleted and we deleted to let Istio discover the services, and by discovering, he will inject those new proxies. So let's take one of those pods here and just describe it. So, all right, now what we can see here is, if you scroll up to the top of the description, we have an init container, which is in fact our Istio proxy. So it's been applied as an init container, as a sidecar proxy. And then we have our front-end services, because I took the example of the front-end. So 2 containers are currently running in that same pod. All right, now that we know, what we have left now is the configuration of the hipster shop getaway. So let me show you the file called I made some spelling mistake, but never. Hipster shop getaway, here it is. If I describe this, you can see that I am creating first a getaway. So let me scroll up to the top. So I'm creating a HTTP getaway for the hipster shop. And this will be accessible from the port 80. And then side of the getaway, I need to define a virtual services to see which application will be called. So here, in my case, it's a hipster shop. So the application is front end, and the application is exposed on the port 80. Then I have another gateway here for. Oh, I made a small mistake here. You can, kubectl has been introduced here, so it's the Istio system. And you can see that it will be accessible from the port 8080 from outside of the cluster, and that will be routed to Grafana on the port 3000. And last, we have Kiali gateway on the port 8081, and that will be routed to the application called Kiali on the port 20001. So that's kubectl. I don't have to precise the namespace because everything has been precised in the metadata of my deployment file. So here it is. I just have to refer to that file, which is the hipster shop whatever. And now you can see it's creating all those various getaway and virtual services. All right, so now we have most of the things that we needed. So let me jump to this Istio ingress API, which is here. So I'm just going to do a refresh on GCP, and you can see that I have the ingress API here with the various ports. So let's test the first one. So this should point me to the hipster shop. So here I have usually the card services is not responding. So, but it seems to at least forward the request to the right front-end services. I have a back-end service that doesn't work. But I'm not here to debug this situation. I'm more about looking at the various components. So now next, I want to see the 8080. So this is bringing me to Grafana, which is I'm here. So now I have a Grafana available. So if I can look at the Grafana settings. And last, I have 8081, which is Kiali. And you can see that here is Kiali. I have, so Kiali is basically interconnected with Prometheus to get the data exposed by the various envoy proxy. You can see that hipster shop has been labeled. So this is how we get some traffic. So we are able to get some details there. But if I jump into those sections, I can see apps. So very important. So I need to select the app, of course, the namespace that I like to look at. But here you can see that basically I have a red. There's a problem with the card services. That's why it's not working. But you can see that application in general is related to a specific label. So don't forget to put the Kubernetes label on your services and pods called app and then equal, because that will allow you to have the right naming and the right structure in Kiali. Otherwise, you can have surprises. Workload, same thing. I can, of course, jump into one of those service, and I can see what is the current traffic between the services. I can see the traffic in general and logs, and I can see the incoming traffic and outbound traffic. So here I don't have much, but at least you can see that I have a lot of things. And of course, traces, but here I have no traces. I didn't do any much traffic. And last is graph. So graph is something that I really like, to be honest. So I didn't do much, just install this connected Kiali with Prometheus. And because Prometheus Envoy proxy is exporting the incoming and outgoing traffic, he's able to create that graph and showing you all the traffic. So you can see that we have a load generator that forwards the traffic to the front end, and the front end then so basically I can have the entire network diagram of the application just by looking at this, even if I didn't have any knowledge on the application. I can also look at the graph per services, per version. So here we don't have any further other versions, but I can look at the app. And basically it's very intuitive, very simple to use. As you can see, we didn't do much, just a couple of deployments. I just did the configuration of the virtual services and the gateway to allow me to have access to those UI, web interface, by just touching those two CRDs, like I said, the virtual services and the gateway. What I really like is the fact that from one given, you can see that from one specific service, I can see the traffic, the ongoing traffic, and you can see that it's currently applied with SSL. So I didn't touch the settings of Hipster Shop. It's been basically Istio who did it automatically. So this is just amazing from my perspective. And as you can see here, I can see the various metrics of the inbound traffic, and I can see the traces is here. So if I click on one of those spans here, I would be able to look at the details of the span.
All right, so that's it for today's episode. I think we explained ServiceMesh and Istio. I'm just amazed to see all those features provided by ServiceMesh, like the observability, all the communication that it layers to apply security and many other features. It's so amazing. So we did a couple of things today in the tutorial. We didn't go too in advanced. So we didn't do any multi-cluster communication. We had only one single cluster, but I think you understood the principle, and you can see the value of that. So if you like the content, don't forget to subscribe and like the video. If you have any topics in mind that make sense for your projects, let me know, and I will try to build an episode on this. All right, thank you for watching, and see you soon. Bye.